is to the right, okay.
It's the gas.
There we are. Woo! Oh my goodness. Alright, does he want me? Yes, he wants me to take that. Oh my god. Wow.
Okay, now relax. And you don't have to brake, you just have to release
Yes.
I'm finally sitting here with Professor Barabazi, who basically arrived today instead of yesterday from Boston. What complex situation brought you here so late?
Well, all the regular networks broke down. The transportation network, the communication network, and I don't know, even some elements of the links actually broke down as I arrived here because they couldn't open the luggage anymore.
Yeah. Wasn't it that you also planned just in time and that there's an instability in that area?
It is true that we do have a philosophy that if you never miss a flight, you are spending too much time at the airport. That bank said this was honestly nothing to do with me.
Welcome to Amsterdam. Yesterday we heard your talk where you talked about the network and about your philosophy. If you look at complexity, we use it in all kinds of different industries, from medical to economics to financial. How can we design a common theme and a common language to use all those tools and those theories to apply in all these different fields?
The biggest problem with complexity is precisely because so many fields want so many different things from it. So I don't think that we will ever have a theory that will satisfy all the needs. Sociologists think very differently about complexity than computer scientists or physicists or economists. What we can hope, however, is that we can understand complex systems, which is different from a theory of complexity. And I think through the network component, we're really getting an angle onto that, because most systems that we perceive as being complex are also networked, that their complexity is really coming from the many components that interact with each other in a non-trivial way. So we have an agenda, we have a program how to follow that. You need to understand who are the components, you need to understand the interactions between them, build a network, and then the final step is to understand the dynamics of the system. If we get there, if we understand the dynamics of these real networks, I think we will have something that you would call complexity theory.
And also complexity tools, so that not everybody has to reinvent the wheel for everything.
I would say that those are already out there. I mean, we have very good tools to kind of map out these networks. We have very good tools to diagnose them, understand their behavior, and so on. What we're missing is a modeling framework that kind of can tell us the future of this system. So the predictive tools that are somewhat more limited. But diagnosis-wise, in the last 10 years, there were huge advances. This goes, of course, hand to hand with the big data story, in the sense that the reason why we can increasingly describe complex systems is because we increasingly have access to data about their detailed behavior. Not only just how the system behaves, but every single component, what they do in real time.
I'm asking you because in the Netherlands we use complex theory and complex research programs to have a lot of different fields work together. And we've been very successful in the first round. And we want to think with the second round research funding, we want to say, how can we get the fields more connected and to use each other tools and each other methods and each other's theory more? What would your recommendation be for that second program?
Well, you know, in a way, just getting people together is the first step in this direction, because this is what we're finding as well in network science, is that the tools are transferable, and colleagues of yours may have tools that you need, but you were never aware of it. That awareness is kind of emerging through conferences too.
We did that 5 years ago, and we have already 15 or 25 programs where people basically are sharing all these tools.
That's right. So you're in the right direction. Now the question is, have the breakthroughs happened through that? And the breakthroughs are subtle in a sense that you know, I always think that the goal is not necessarily to make a breakthrough on complexity, but rather to use the complex systems tools to understand cancer, to understand economic behavior, and so on. So the breakthroughs are often disciplinary, but the tools are interdisciplinary and the approaches are interdisciplinary.
Suppose we had 20 million in research money to distribute. Would you say do huge big projects of 5 million each or small ones, or what would your recommendation be? What kind of tools and what kind of teams to support?
Well, first of all, I hope you do have 20 million for complexity.
Not yet, but we're working on it. Yeah.
Second, I personally believe around the small teams. If you think about most Nobel Prizes came out from labs that at the time of the discovery, they were small. Later, they grew by...
How much is small? 10, 100, 1,000?
I would say 4 or 5 people. That's kind of the optimal size for really making big discoveries. Now, there are certain problems that cannot be addressed at that size, and we have to be aware of that. And sometimes you need a group of 20, you give bigger groups, or sometimes hundreds. But I think for making theoretical advances and for understanding complex systems, small groups will be the key. 2 or 3 investigators working together with 2 or 3 students focusing on certain problems, because that's the level where kind of creativity can be managed and can be transferred from one person to the other one.
Other recommendations, apart from the teams of 3 to 7 people?
Don't be afraid of complexity, and also be aware of the fact that this is really the 21st century, and much of the industry and much of the excitement happens in the 21st century is because of networks, is because of complexity. So we must address it, and I think if you invest in that, you may be riding a wave that will be the wave of the future.
Yeah. You are very known because of your network theories, and you've done it for a very long time. In medical, you started to apply it. I saw a TED talk, but you also are looking at the chances of success in the complex. Can you tell me about that?
Sure. Much of the work we did in network science until now has focused on how does a network look like, what are these universal properties. We increasingly start asking outcomes. How does the network affect a certain individual to succeed in a certain area? And often that becomes divorced from the network. The question is how you quantify success. What are the kind of preconditions, the measurable preconditions? And the philosophy of this work is really that success is not an individual phenomenon, but a collective one. You are successful because we all agree that you are successful. If you believe that, then suddenly success has lots of fingerprints around the society. So I can gauge your success by looking at others and others' reflection of you. And if you and so therefore it becomes quantifiable.
Yeah, like Google basically saying this page is successful because of not because of the page itself, but yeah.
Because many other point to it and so on. So that's exactly right. So the question is how you extract this information from the data out there. What is the right measure of success, and can you actually predict it? And in the case of scientific success, we recently published a paper in Science where we were able to predict 5 years after the publication the total number of citations ever a research paper will get. We call it the total impact. And it turns out it's a very accurately predictable quantity. So that's kind of a small step in that direction. And we're kind of increasingly looking at the question, how does performance and success correlate? Because it's not the same thing. And that takes us to very interesting areas, like sports, because their performance is very precisely measured. And success is a different dimension. Often, and then it's also a winner takes all market. If you are the first in the Olympics or the second makes a huge difference regarding.
But are you already is it already that you had some prediction because of the network, what behavior, who is going to be successful in the future? Because of course that's the holy grail.
That's what we're heading for. But what we realize is that before we go to the network, we first have to understand the measures of performance at the individual level. And then we can go to the network effect, which is really the recognition.
So it's basically work in progress.
This is all work in progress, yes.
Thank you.
Thank you.